Hello, once again, welcome to my YouTube channel. Today, we are going to be discussing the concept of GitOps and ArgoCD. This is an important concept in software and application delivery or deployment. But for you to better understand and appreciate the concept of GitOps, I'm going to quickly run you through the traditional process of software or application deployment. In the regular or traditional way of deploying application, we have a CI/CD pipeline as shown on the screen here. You have your source code, and then you have a developer, working on this source code. So the traditional concept will be that a new branch will be created out of the original or out of the main branch, and changes, contributions, and what have you can be done on the new branch and committed to the new branch. When that is done, then it is being pushed, and then that will trigger a CI process, which is the continuous integration process, which could include code scanning, code testing, application build, build, image push to registry, and a final deployment into the necessary environment. But in this case, after a CI is being, the CI process is being initiated, then, the code will be reviewed by a more senior developers. Then if the code is approved, then it's going to be merged back to the main branch, and that will trigger a CD process. The CD process will complete the deployment into, let's say, Kubernetes, as the case may be here. This is how the traditional CI/CD pipeline works in the traditional um, application delivery or deployment. Now, but the problem we have here is this. If, for example, a change is made in the Kubernetes hand of this application, of course, you know that changes can be made directly on the Kubernetes using, maybe you edit the YAML file and you run a kubectl or kubectl, and make the change on the Kubernetes, and the Kubernetes still keep running. These changes here is not reflected in the source code. So if in case of any disaster and something happened, and we lose the cluster, we lose the Kubernetes cluster, and we are trying to recover, do a disaster recovery for the application, we'll find out that the change that have been made in Kubernetes before the cluster was lost was not updated in the original repository. So there's what we call configuration drift. There's a drift between the source code and the current state of the application before we lose the Kubernetes. So this is the problem. This is one of the problems that GitOps will intend to solve. So then, what is GitOps? So what is GitOps? So I have a short definition here. We are not going to be reading through everything, but I will just quickly explain what it is. So GitOps is a framework where the entire code delivery process is controlled by Git. So in GitOps, the entire code configuration and infrastructure configuration are what's stored in Git. In GitOps, infrastructure and application configuration are defined as code to enhance seamless automation of the deployment, changes, and rollback processes. Because your code is stored in your configuration is stored as a code in your Git repository, be it GitHub or Bitbucket or GitLab, as the case may be. And how does it work? I try to explain here the traditional CI/CD pipeline, which I just explained just now. I said traditionally a developer will create a feature branch, from the main branch. When the developer commit a code, then they push it, blah blah blah. You know what that is. Then there will be a merge request and all that. Then the CI/CD pipeline will be triggered. Now that is just what I've just explained to you just now with the traditional CI/CD pipeline in the regular DevOps process of application delivery. But in GitOps scenario, an automated process ensure that the desired state in the repository and the actual state in the production environment always matches. I'm going to explain all this to you with a diagram. So we have a GitOps operator. There's something we call a GitOps operator. In this case, we are going to be talking about ArgoCD. That is an example of a GitOps operator that run within one of the Kubernetes cluster. So that is one thing that you have to note. ArgoCD will be running directly in the cluster, on the Kubernetes cluster, and continuously monitors and pull changes to the GitHub repository and apply them within the KS cluster that is running. And it can also be applied to different cluster as well. So when the developer pushes changes to the Git repository, the CI pipeline is triggered that containerizes the code and pulls the image. Okay, I don't want us to waste so many times on this. And then this also update the Kubernetes manifestation file. I'm going to explain all of this in just a minute. And I said the GitHub operator, which is ArgoCD in this case, that is running the cluster now identify the difference between the desired state that is found in the Git repository as versus the actual state of the cluster, and then pull the changes and make sure that the desired state always matches the actual state. Yeah, I'm going to go ahead and explain that. And we have the principle here. I'm going to add this document to the link. You can download it and just go over it. It is very self-explanatory. Now, one important thing I actually want to iron on here is the GitOps principle. Now, we have three fundamental principles that we follow in GitOps. One is your configuration has to be declarative. And that is why we use the YAML file, the YAML manifest file, because we are going to state clearly or declaratively what you want your code to do. Then there's something we call version control. The code has to be what? Version control. You must be able to manage the source of your code. And in that case, there's something we call a single source of truth. So your Git repository will now serve as the single source of truth in the sense that all configuration, all changes that are going to be made to your application and your infrastructure are going to be sourced from the Git repository. And the last one is what we call auto reconciliation. Auto reconciliation is the ability of your infrastructure to be self-healing. You must be able to observe, the difference, because in the process of carrying out the auto reconciliation, it's going to do something it's going to observe. And in the observe step, it's going to check the Git repository for any changes in the desired state. I'm going to explain that. And also the difference, it's going to compare the difference between the current state and the desired state, and it's going to act. And it's going to use what we call the reconciliation function to reconcile the two states. So I'm going to take you through another picture again. Let's see this diagram here. Now, this is a complete GitHub process. So you have your application repository, okay, and you have another repository that contains the GitOps files, which is the configuration and the application file. So in the normal CI process, don't forget that your GitOps is more interested in the CD hands of your pipeline. It's more interested in the continuous delivery or continuous deployment portion of your pipeline. The CI pipeline, you can still use your regular tool like your Jenkins or GitHub Actions to carry out the CI portion of your pipeline. But the CD part will now be handled by ArgoCD, which is a Git operator in this case. So we have an irregular process here. We have the unit test. That's the code. The code will be tested. An artifact will be built. You can use your Maven to build the artifact, and it's going to be stored in an artifact story like JFrog or Nexus. And then after that, an image is going to be built using Docker, and that image will be pushed to the repository. Now, when the image is pushed to the repository, this is where the CI process ends. Now, what happens? If it were to be in the traditional DevOps, this process will now trigger the CD process that will complete the application and then deploy it to Kubernetes in this case. But in this case, what happened is immediately the image has been pushed to the registry. Then the YAML file in the second repository, don't forget we are having two repositories now, one containing the source code and the other one containing the YAML deployment and service Kubernetes manifest repository. So the image information will be updated on the inside the repository on the deployment and the service .yaml file in the second repo. And so when this information is updated, then there is this GitOps operator, which is ArgoCD in this case, that is constantly probing this repository for changes. It's constantly looking for changes in this repository. And immediately it has a change, it saw or you notice any change here, it's going to pull the change and update the Kubernetes cluster and deploy any changes that it found here. So unlike in your in the traditional CI/CD pipeline, where a pipeline is being triggered when a code has been pushed or committed to the main branch. In this case, it is a pull process. It is the ArgoCD that goes into the file, see a change, and pull it. So the state inside the Kubernetes manifest repository is what we call the desired state, and this is the state that you want your infrastructure to be at every point in time. Why the state at the other hand inside your Kubernetes cluster is called the current state, because that is the state in which the application is currently running. So the main job or the main function of the of GitOps operator is to reconcile the desired state and the current state and make sure they are in sync at all time. The main function, I repeat, of GitOps operator, which is ArgoCD in this case, we have another tool called Flux. Yeah, it's also work like ArgoCD, but the advantage or let me say ArgoCD is more popular because it has a graphical user interface, while it has both graphical user interface and the command line. Why Flux is mainly command line, so people prefer to interact with GUI. So what the work that it does is it will constantly make sure that the desired state, which is the state you set up in your Kubernetes repository, matches what you have in your Kubernetes cluster. So even, for example, if inside my YAML file, I have indicated that I want to have 5 replica of, or let's say 4 replica of a pod. So if 4 pods have been created here, if I go ahead and remove 1 out of the pod, the GitOps operator will go back to the file here. Don't forget that it's constantly checking it. Go back to the file here, and you will notice that the replication is supposed to be 4, but at the current state it is 3. Then he will come back and create another one automatically. So it makes sure that at every point in time, this desired state and the current state are the same. So even if there's a disaster and we lose any of the hand, either we lose the Kubernetes cluster, we are very sure that the file inside our Kubernetes manifesto repository remains up to date. So in this case, your Git repo where the Kubernetes manifest repository is being saved now becomes the single source of truth, because that is the only point that controls the application and the configuration of your infrastructure. So that is the main concept of GitOps using ArgoCD. I'm also going to show you one more diagram for better explanation. Okay, can you just look at the diagram on the architecture on the board? So we are going to be having two repository. This is the repository that contains the source code that built the application. And we have another repository here that I call repo2, which contains the YAML file, which is usually the deployment and the service file that runs the infrastructure. So when there's a change or there's a code that's been pushed by the developer in the application source code. And of course, during your Jenkins process, there's going to be a CI pipeline that will run the test, the scan, build the app, and and push the Docker image. Immediately the Docker image is pushed, the CI process is completed. But what happens is there's going to be update manifest file. The information we got here, let's assume we change an image here as we are going to see in our hands-on. If the image here has been changed from version 1 to version 2, then the file here will be updated to what? From version 1 to version 2. And immediately this file is updated, ArgoCD will notice that there's a change in this file, and it's going to pull that change and deploy the application into the pod. That is what ArgoCD does. So this is a very fantastic one, and we are going to be seeing it in a demo. So in our hands-on, we are going to be using AWS EK cluster, that's Elastic Kubernetes service cluster. We are going to build a cluster. Then we will assume that the CI pipeline, the CI side or the CI portion of the pipeline has been completed. So we are just going to be starting from the image where the image has been pulled, and then we are going to we are going to configure the image and pull it into the repo, and we'll see how ArgoCD will pull it and create the appropriate pod. So let's jump into the hands-on right away. So I'm going to go to my AWS console, and then if you can just type EKS, or unlike me, I already have it. At the top here, so I'm going to open EKS. Let me close this. I'm going to open EKS. So the first thing we want to do now is to create our Kubernetes cluster. Now, before we create our Kubernetes cluster, we have some role that you have to create, and I made a video on how to create a Kubernetes cluster. So you might want to check it out to know how to create a Kubernetes cluster. So I've listed some steps that we're going to be taking here. We are going to create a role which I've already created, so I'm not going to be wasting our time on that. We are going to create a role called EKS cluster role, and we're going to create another role called the node group role. These roles are essential for your Kubernetes to have the appropriate permission to carry out the processes. So I've already created this role, and I'm just going to be using them right away. So the first thing you want to do is you want to click on create cluster, either here or at the top. Go on create cluster. So I'm not going to be using this. This is the new, the latest add-on from AWS that we call EKS Auto Mode, where you can provision your EKS to run on what I call autopilot. It's an interesting one, and I'm planning to make a video on it. So I'm going to be using custom configuration, and so I will disable auto mode, and I'll call my cluster let me call it web app. Okay, I'll call it web app cluster. And because I've created the role, so I will select my EKS cluster role here, and then I will just leave every other thing to um to the I will leave every other thing to default as it is here, and I will click on next. I think we're fine. So I will click on next. Then I'm going to be leaving it in the default VPC. And I know that Kubernetes cluster cannot be created in the USE, so I'm just going to take that away. And then security group, I'm not going to be, I will just allow it to create a security group by itself. Then for the cluster endpoint, I will just leave it as public and private. But okay, let's select a security group here. I have a security group that I've prepared already. I'll show you guys. There's one that I've made, an K8 master security group. Okay, that's the what I want to select. Let me quickly show you what that security group look like. I hope if I can see it very easily. So I've done it, excuse me, and that's what I usually use. Security group. I hope I can see it clearly. Okay, that is it here. So I've opened a number of ports here because it is generally used. So you can just take a screenshot of it and you can open it too. So these are ports that are generally used, in a lot of processes, either for HTTP, HTTPS, for Postgres, database, and all that. So you can just open this and make it your general security group. So I've selected that, and I will leave this one as a public and private. I will click next. Metric, I'll just leave it as it is. I'll click next. Then I'm going to leave this as it were. If you like, you want to add any add-on, but just make sure you don't remove anything from the one that are already pre-selected. So I will leave it as it is, and I will click on next. And everything look good to me. Go through it, and then we'll just go ahead and create. So after that, I will move on next, and I will click on create. So I'll click on create. So usually this take between 8 to 10 minutes for it to be created. So I'm going to pause the video, and when the cluster is created, I'm going to be back and we'll continue from there. So I will see you in few minutes. Okay, welcome back. So after about 9 minutes or thereabout, our cluster is finally created. So if you look at your screen, this is your cluster info, and cluster is if you look at it, this is our cluster here, web app cluster, and it's active. So the next thing that you want to do now is to create a compute capacity that will run the load of your application. Create the compute capacity that will run the load of your application. So in that case, you go under compute. I also had, I have a video on this, so you might want to check out the video. So if you click on compute and you scroll down, there's something called node group. So we click on add node group, and we are going to run some configuration. So in this node group name, I'm going to call it, the name of my application, I'm going to call it nextcloud app. I'll just call it nextcloud because that's the name of the application I want to deploy. Then I will select the IAM role that we created, that I said we are going to create. That's one of them, two of them. So we have used the other one for the EKS cluster, and this one is for the node group. So we're going to select it. And after that, we'll select next. And here we can select whatever we want. You can select, you can see we have a lot of AMI type that you can use, but we'll just go with what is pre-selected. And you also have capacity either on demand and on spot and spot. You know what that means. On demand is your pay as you go. Spot has to do with bidding. If you are using it and somebody bidded for a better price, Amazon has the right to pull it from you. So I'll just go with on demand, and then instant type. Let me just use T2 medium just for the purpose of this. Let me use T2 medium. I'll use T2 medium, and I will remove this T3. Then I will leave the disks at 20 GB. And now this is the auto scaling. So the desired state, you know what desired state, meaning that at every point in time, you want to have 2 nodes running. The minimum state also telling you that when you say minimum, it means that when it is downscaling, it must not go beyond 2. Or I can change that to 1 if I like. So, and the maximum meaning that your number of node running at a particular time cannot be more than 2. But let me just change this one to 5, meaning that I can have as much as 5 nodes running at a time. So I should look at this one too. Node group update configuration, meaning that if the configuration needs to add, if there's a need to add more node, that is when it is upscaling. How many nodes can be added at a time? This is where you can change the number. So with this number 1, meaning that if there's a need to add an additional node, you go to add it 1 after each time. So, and then we'll go ahead and we'll click on next. And this one will just automatically select the subnet that we have before. So I'll go ahead and click on next, and then everything looks good to me. So this also takes a couple of time. So we'll just go ahead and click create. So this is going to take almost very close to what it took Kubernetes to run, let's say another 5 to 10 minutes. So I'm going to pause the video, and when it is the node is created, then we are going to come back and we'll continue from there. So I will see you in the next few minutes. Okay, welcome back. And just after about 5 minutes, our node have been created. So if you look at the status, it says active, and there's no health issues. You can see health issues is 0, meaning everything is up and running. So if you click on node, you'll see that 2 nodes have been provisioned. Don't forget, we indicated that we want desired node is 2 nodes. So we have 2 nodes of each of them are 2 medium, and they are ready to take your application load. And if you go into your, don't forget that these nodes are merely EC2 machine that have been created to carry. So if you go to EC2, let me click on EC2 here. EC2. If you click on EC2, and let's open it another tab. If you click on EC2, you will see instant running. You can see 2 instances running. And you can see these are the 2 instances running. These have been provisioned to run as a node. Don't forget, we did not create any EC2 instance. So now, a node has been created. So the next thing we have to do now is to go and set up our ArgoCD. So I'm going to bring up my terminal. And the first thing, in your own case, the first thing you want to do is to configure your credential, your access key and secret access key, so that your terminal will be able to communicate with your AWS. But in my own case, I've done that. So if I just type AWS configure, it will let me know that you can see I've configured it before. So it's showing me if I still want to use it. Yes, I want to use it. So I just click it as default. So the first thing we want to do is I've also installed kubectl here, kubectl, which is also another Kubernetes tool. So in your own case, you decide to use AWS Cloud Shell, where in that case, you don't need to configure kubectl or not. But in my own case, I want to use my terminal, so I need to install kubectl or kubectl. That's what some people call it kubectl. Some people call it kubectl, and that is the tool that allow you to communicate with your Kubernetes cluster. So the first thing I want to do here now is to go to this link. I'm going to provide you with this link, and we are going to put this command there. And that command is to update our kube file. Kube config file is the one that allows Kubernetes cluster to authenticate with the nodes that are coming. So I'm going to go ahead now and paste it. Where's my terminal? So I'll go ahead and paste it. But look at it, it has to be in the region, because it has to be the region, which is my region, US East 1. And the name of my cluster is webapp cluster. You have to be sure. Let me show you. If I click on cluster, the name of my cluster is what? Webapp cluster. Okay, you can see it here, webapp cluster. It has to be exactly what you have in your name of your cluster here, webapp cluster. So I'll just go ahead and click enter. So you can see that has created a cluster. And now if I type kubectl get nodes, so that's it has given me the 2 nodes that are already running in my cluster. And you can see the status is ready to get job. So I'll clear it. Now I can also do kubectl get all as all wide. So this is going to give us the services that are created and in Kubernetes and all that. But now the next thing to be done is, if I say kubectl get namespace, you see that we have only 4 pre-configured namespaces. We have the default space, the kube node, the public. So we need to create a namespace where ArgoCD will run. So in that case, we're going to copy this command. And what that command will do is going to create what? A namespace called ArgoCD. That is very important. It is inside this namespace. Namespace is like an isolation. Don't forget, we said we have created our cluster, we have created our node, and we have said that ArgoCD is going to be installed. It's going to be only on your Kubernetes cluster. So it needs to run in its own isolation, in its own namespace. So that's why we need to create a namespace for ArgoCD. So now a name has been created. So if I go back now and type kubectl get namespace, you can see a namespace called ArgoCD has been created. And we need to be making reference to this name at all time. So I'm going to go ahead now. The next thing now is we need to install ArgoCD and all its dependencies. So we're going to copy this command. I'm going to paste it. I'll just clear and I'll paste. So look at it. This is an YAML file that has been created, and this is going to install ArgoCD and everything that comes with it. So it's going to insert a lot of information, a whole lot of information is going to be installed. Now it is done. And so if I clear here and I type kubectl get wide. Now let me put the namespace there. kubectl get all namespace ArgoCD, that's all wide. So you can see this is all that have been created. Everything that we created has created pods, it created service, it created deployment, it created a replica set, and a whole lot of them. Now, in the whole lot of this, what is very important here is what? Our ArgoCD server under the service. Okay, under service, we have what? ArgoCD server. This is it here. ArgoCD server. That is what we actually need. So I'm just going to limit it to what? To service. So I'll just say kubectl. If you don't want to type complete kubectl, you can just say alias k equals kubectl. What this means is that anytime you type k, it's going to recognize it as, anytime you type k, it's going to work as kubectl. So if you just put it like this. So if I say k instead of kubectl, I say k, that is kubectl get nodes. You can see it is still working. So, but meanwhile, it's going to work just for this session. If you close this session and you leave out, it's going to go back to its normal kubectl in full. So now I'm just going to say kubectl get service namespace ArgoCD. So this is the service. And now, how do we access this ArgoCD server? Is what we need to access ArgoCD. But if you look at it, the type is in cluster IP. Cluster IP is meant for internal communication of between pods or between services in Kubernetes cluster. It is not meant for external communication. So we have three or four main type of way we can access our cluster. We have cluster IP, we have node pods, we have load balancer, and we have ingress. So for um, cluster IP, it is mainly for internal communication, and you cannot access your pod through cluster IP. You can either do it through node pod, through load balancer, or through ingress. But you didn't want to do node pod because node pod, we expose the pod directly. We will expose the access directly on the pod. Okay? Unlike your load balancer that will create access from the external point onto the pod. So the best way to do to the best access to use is either load balancer or ingress. So in this case, we are going to be using a load balancer. And so for us to use a load balancer, what we need to do is we can edit our access. We have a simple command to do it, but I'm going to show you both ways. You can edit the access of your cluster IP and change it to load balancer, or you can just run a single command. So let me first show you that of edit. So you're going to say kubectl edit. We want to edit this service, ArgoCD. We want to edit it. So I'll copy and paste it. And in what namespace? In namespace ArgoCD. Sorry, whatever. Okay, sorry. It is edit service. Edit service. And the name of the service is ArgoCD and a namespace called ArgoCD. Let me put you through again. kubectl edit service. The name of the service is ArgoCD server, and the namespace is ArgoCD. So it's going to take us. So now, if you look at it, this is the manifest file for the service. So all you need to go down to where you have the type. Look at it right down here, where you have the type, and you will change it to load balancer. So I'm using VI here, so I'm going to press enter, insert, and I'm going to come here and I will remove this and I'll change it to what? Load balancer. It has to be written this way, capital L, capital B. And I will what? So after you have changed the cluster IP to load balancer, then all you just need is to quit. I think quit, save. So if you now get a service, kubectl get service ArgoCD, you can see that we now have a load balancer. You can see we have a load balancer instead of cluster IP. So that is one way to do it. So the other way is to just use a simple command to change the cluster IP to a load balancer. So I'm going to go back. I'm going to change the load balancer back to cluster IP, and I'm going to use the command to execute it. So I will go back and edit, kubectl edit. So I will go straight down to where I have where I have load balancer, which is here. Then I will press I to edit because I'm using Vim or VI editor. Then I will change it to cluster IP. Then I will click escape, Q, save. Now, if I get service now again, you can see it has returned back to what? To cluster IP. So, but instead of going through the process of editing and changing it to load balancer, we have a simple command here that you can use. I have the command here. I'm going to put this document in the link below, and you can access it. So I'm just going to clear this, and I'm going to paste the command, and I'm going to click enter. So now the patch has been completed. If I go back and I do ArgoCD get service, you can see it has turned to load balancer. So you have the option of either editing the YAML file, or you can just run that simple command. So now we have the URL through which we are going to watch, through which we are going to access our ArgoCD. So I'm going to go ahead now, and I'm going to go ahead and paste it in the URL. Sometimes it might take a few seconds to come up. So now we are going to access our ArgoCD. Now, after accessing ArgoCD, then we need to log in into ArgoCD. So see here, I don't know why it's not coming up. Let's give it a few seconds more. Okay. Let's allow it a few seconds. Okay, now we got it. So if you click, we are bypassing the security, and now we have our ArgoCD. Now we need to log in. The username is admin by default, and we need to get a password. So in getting the password, there are two ways, or so many ways to get it. One of the things you can do is to get secret. I already have a command too that I can use to get it. But you can you can say kubectl get secrets. If you do kubectl get secret, yeah. So this is the secret of the which if you look in the secret, we have ArgoCD initial admin secret. That is the first password that we use to log into ArgoCD. So I can copy it, and I can come here and say kubectl get secret, and I'm going to paste that secret that I copied in ArgoCD, and I want it to give me in terms of JSON. I want it to give me in terms of JSON. And so you can see this is the password. But this password is encoded in base 64. So we need to what? Decode it. So I can copy it. I can copy the password, and I will decode it. And how do I decode it? I will echo the password, and I will pipe it through base 64. I'll pipe it through base 64 in the detach mode. So you can see this is the password at the back here, just from here up to the back of the admin. Alternatively, if you don't want to go through all this, you can just use a simple command. I have a simple command here. That command is the combination of all these processes. And that's it here. I'll just copy it, and I will paste here. You can see it just gives us the same thing. You see it? So instead of go through the process, you can just use this. So I'm going to copy this and I'm going to take it to as my password, and I'm going to sign in. So now I sign in into ArgoCD. So the first thing you want to do is to go and change and update the password. So you're going to put the current password, and you're going to change the password. I'll change it to Felix, the 081. I'm also going to put it as Felix 081, and I will update save new password. Okay, so the new password will be changed. So if you click on anywhere, it's going to log you out, and you have to log in back by yourself. Admin, then release 081. So I'll sign in, and now this is the ArgoCD interface. So the next thing we want to do now is to connect our repository. So let me take you to where our repository is. I hope I can see it. I'm looking for my repo. Let me check here. No, that is not what I want now. Okay, let me use this. Okay, so this is the repository I want us to use. So now let me quickly show us what we have there. So if you click on this K8 manifest file, we have two manifest files now. We have the deployment file where we want to deploy this application called nextcloud, and this is the image of the application. I'll show you where I got the image. And then we have the service file, which create the service of load balancer that we can use to access our application. Now, this is where I got my image. This image was gotten from another AWS account where I have my image saved in my ECR, Elastic container registry. So this is so if I go to repository, my public repo, this is the image that I use. So if I click on the image, click on it, and this is the URL of the image. That's what I copied, and that is what I put here. You should see it here, line 18. That is what I put here. So I'm going to be connecting this repository to my ArgoCD to pull the image. Now, what is this deployment doing? What is it doing? One is the kind is deployment, and the name of the deployment is web app. The name of the application is nextcloud, and the image is from here. And look at the replicas. I asked it to have 5 pods, to create 5 pods in the process. And in the service, we have service 1, and it's going to be exposed at port 8080. So I'll go ahead, I will copy my repository. This is my repository. It's a public repo, so we don't need credential. So I will go over. So in your ArgoCD, you're going to click on settings. You click on repository. You click on connect. You can connect through so many ways, through SSH, but I'm going to go through HTTPS. So what I have here is Git. I'll select Git. Project name, I'll select default. Repository name, that is the name of my repo that I just copied. Then there's no need for username and password because the repo is public. And I will go ahead and click connect. When you connect, you can see it's a successful. The connection is successful. And so the next thing we'll go ahead now is to configure. You can click on it here and click on create application, or you can just go up to you can go up here and click on new application. Okay, but I like to go through my repo. I like to go through, and also I can come here and click application. What is the name of my application? Nextcloud. That's what I want to call it. Nextcloud application. What is the project name? Default. We have the option to either sync manually or automatically. But of course, what is the essence if we cannot do it automatically? So I'm going to select automatic, and I'm going to select here prune process and self-healing. Prune process means if I remove any of the app, any of the pod, then ArgoCD should be able to remove it. So we also remove it there. Then we also have self-healing. if there's any destruction, then ArgoCD will automatically create another one. So, and also auto create namespace. This one means that if there's a namespace that does not exist and I want it, I can ask ArgoCD to create it. And so this is this is my repo, and the head. The head means that I'm considering branches of my repository. So it means it's going to be taking the last commit. The last commit on the repo, that is what it's going to put. That's the meaning of head. And what is the path? If you go into my repo, where's my repository? Sorry. Okay, if you go to my repo, you can see that it is inside this K8 that we have the file. So my path will just be K8 because it is inside K8 that you have the files. So I'll come here. So my path becomes K8. So destination URL will automatically, since you have choose default, it's going to pick default. Namespace, let me call it nextcloud, since I want it to create a nextcloud app. So if this doesn't exist, ArgoCD will automatically create it. So I think I think everything is fine. Then you go ahead and click on create. So and let's watch it. You can see it's syncing. And if I click here now, you see it. You can see automatically it has created a nextcloud, and it has created a service called webapp self. If you look at it from our file, it has created deployment. And don't forget, I told you we asked it to create 5 pods. So you can see this is 5 replica. So you can see this is the work of ArgoCD. So now everything is completed, and I can come here, I can come to service and click on detail, and I can take this URL, and that is where we are going to access our application. So I'm going to put it here. I'm going to put here. I'm going to click on enter, and I hope we should be able to access our application. So let's give it a few minutes for applications to come up. Then we'll come and refresh. So if you look at it, that is our application. So if I come here now, for example, since ArgoCD now will constantly be checking the repo for any change. If there's any change in the repo, ArgoCD will respond immediately. Let us see if our application can be accessible. Okay, you see, that is the application. Our nextcloud application is accessible through the URL. So now, if I go back to my repo, let me go back to my repo. And let's say I went into deployment and I change my replica set from 5 to, let's say, let me say I change the replica set to 10. Let's see what happens. And I commit. Don't forget, in production stage, you can't commit directly to the main branch. So what I'm going to do is to create um, um, a new branch and create a pull request and merge it. But just for the purpose of this class, let's commit directly to main branch. So I've done the commit. So now let's go back to our this is my ArgoCD now. If I just refresh now, you will see what happened. You see, it has created 10 pod immediately. It has created 10 pod immediately. Now, if I go back there and I, let's say, change it again to, let's say, 3. Let's scale down to 3, and I commit. And don't forget, ArgoCD will pull the last commit. So if I commit now, if I go back and I refresh, you'll see it immediately. It will scale down. You see it? It has scaled down to 3 pods. Now, if I come onto the Kubernetes side, let's assume we have said that we want 3 replica. If I go ahead and delete one of the pods, you see it. If I force delete, immediately it will create another one. You see it. It bring it back because I have told my YAML file that I want 3 pod in my deployment. So if I try to remove it, if I try to remove it, it will force it back. You see it? It will force it back. So that is the power of ArgoCD. And it saves you a lot because if you want to use the traditional CI/CD pipeline to deploy it, you are going to be needing to do a lot of configuration to put in your credential, which is exposing your credential. But in the case of ArgoCD, it's running in Kubernetes, and so you don't need an additional credential to configure ArgoCD to Kubernetes. So this is very instructive, and I believe you have learned from it. Now, ArgoCD also has the command line, which I will make another video where we can access ArgoCD through command line. I hope you learned something in this video. I hope it's of great, it will be of great truth to you. You can go into details, excuse me, and watch further videos or make further research to learn about ArgoCD and how the methodology of GitOps is changing the process or concept of a software or web application deployment. So ArgoCD is taking care, like I told you, we have an alternative tool that is called Flux. Flux also works like ArgoCD, but it's entirely on command line. So people prefer to work with a GUI, a graphical interface like this. I hope you enjoy it, and I hope to see you in the next video. I'm going to add these documentations and all the repository in the link underneath, so you can check it out and practice. Put your comment, and if you like this video, please subscribe and like just to support this video, and all of your support will be very much appreciated. Thank you for watching this video, and I will see you in another video. Thank you.